Right, it's review day. Finally at the end of the trigonometry unit. Test is tomorrow. There's a couple questions I want to go over on the homework to start out with. So the first one I wanted to look at was number 4. These questions are definitely getting way better for people. There's just still a couple issues with them, so I wanted to just go over this one. If cosine of b equals 2/5 and b terminates in quadrant 4, find the value of sine of b and tangent of b in simplest radical form using a picture and using identities. So again, if it doesn't specify on the test, do it whatever way you feel more comfortable with. For me, I'm always more comfortable drawing a picture. I just think it makes more sense and it's a little bit easier. They tell me it's in quadrant 4. So here's a triangle in quadrant 4. And if cosine is 2/5, then the adjacent side is 2 and the hypotenuse is 5. 2, 5. So how do I get the other side? Pythag. So 2 squared plus b squared equals 5 squared, which means 4 plus b squared equals 25. B squared is 21. Take the square root. So b is plus or minus radical 21. And the one thing you got to remember is watch that plus or minus. So it's negative radical 21 because it's going down. All right, and they just wanted to find sine of b, which is opposite over hypotenuse. So negative radical 21 over 5. And tangent of b, which is opposite over adjacent, which is negative radical 21 over 2. And both of those are simplest radical form because it can't be broken down any further, and there's no radical on the bottom. Good. Using identities, if I have cosine and I want to find sine, that's sine squared plus cosine squared equals 1. And this is technically sine squared b plus cosine squared b equals 1. Remember, it can be any angle inside as long as they're the same. Cosine's 2/5, so you should be showing me that sine squared b plus 2/5 squared equals 1, which means I have sine squared b plus, it becomes 4/25 equals 1. Now when you take 1 minus 4/25, again, I think a lot of you could do this in your head, but if you're on a test or something and you have the calculator available, no reason not to, but leave it as a fraction, 21/25. So sine squared b equals 21/25. Take the square root of it. Remember, when you take a square root, you always have that plus or minus. Then you just take the square root of the top and the square root of the bottom. Square root of the top is 21. Square root of the bottom is 5. Now again, the downside with this method is that you have to use all students try cheating to figure out if your answer is positive or negative. And that's why they tell you that you're in quadrant 4. So if I'm in quadrant 4, is sine positive or negative? Sine's only positive in 1 and 2, so it's got to be negative. So the answer is negative radical 21 over 5, which should match what we got before, and it does. Okay, so then if I want to find tangent of beta, how is tangent related to what I know? Well, if I'm using identities, tangent is sine divided by cosine. Sine b divided by cosine of b. So sine of b we just found was negative radical 21 over 5 over cosine of b, which was 2 over 5. We have a complex fraction. The 5's are going to go away because when I multiply top and bottom by 5, cancel out. And I end up with negative radical 21 over 2, which again matches what I got from the picture. All right, so again, I just feel like the picture way is way simpler, but if it does specify using identities, that's how you would do it. Now the back of the homework looks pretty good, but there were a couple things I wanted to mention. A lot of you missed something in 5A. I'm not even sure you realized it. Tides measured from the end of the dock at Pine Island on Tampa Bay can be modeled by this equation. where T represents the number of hours since low tide, Y represents the depth of the water in the bay. Minimum depth of the water is 4 feet, maximum depth is 15 feet. Low tide is reached every 12 hours. So you guys found A, B, and C really well, with one exception. It says determine the equation that models the water depth as a function since low tide. I tried to underline that to get you thinking. It's going from low tide at 4 feet to high tide at 15 feet. So they told you to use a cosine graph, but if this is what your cosine graph looks like, hours since low tide, what type of cosine graph is it going to be? Negative cosine. And a lot of you missed that negative, and it's a subtle thing to miss. Okay, so the actual answer for this one should have been y equals negative 11 halves cosine of pi over 6t plus 19 over 2. And again, pretty much everyone got the actual number parts of them right. You just missed that negative, so double check your answer on that. Same with this. When you're doing your graph, always look at what happens when x equals 0, because we want no phase shift. And even the way this is written, it's no phase shift. It also specifies sine. A couple of you gave me a cosine graph. But if I start at 0, look at where one cycle is. I got to get to that same starting point. So what type of sine graph does that look like? It's a negative sign. So I did have a few of you that found values for A, B, and C correctly, but don't forget and write an equation. So it should have been y equals negative 2 sine of 2x minus 1. So just watch those negatives. Make sure that your graphs agree with your equations. Okay, so that's mainly what I wanted to go over on the homework. Let's switch over to a warm-up for the test. So you should have this warm-up. I gave it, you should have a blank copy of it, but if you don't, you can just write your answers on a separate sheet of paper. But please pause the video and give this warm-up a shot. This is a good indicator of how well you're ready for this test tomorrow. So try these questions, and then we will go on. All right, did you try them? Okay. Amplitude, frequency, period, phase shift, midline, and range, given this function. Things to remember for the test tomorrow. Amplitude is what? The absolute value of -3. Don't ever give me an amplitude that's negative, because amplitude is just the vertical shift, or vertical stretch, which is 3. What's the frequency? Pi over 8. Remember, frequency means the number of cycles between 0 and 2 pi. So we're not going to be graphing between 0 and 2 pi, but the number of cycles would be whatever pi over 8 is. So there's about 0.4 cycles of a sine graph between 0 and 2 pi. It's not even half. Period is the 2 pi over b equation that you need to know. And b is pi over 8. So 2 pi over pi over 8. You'd have to multiply top and bottom by 8 because it's a complex fraction, which would get you 16 pi over pi, but then cancel those pi's out, and your period is 16. So it's going to repeat every 16 units. Phase shift. What's the phase shift here? 0, because it's not shifting left or right at all. There's nothing in these parentheses. There's no plus or minus, I should say. So that's why the phase shift is 0. Midline. Okay, again, be careful on the test. Don't tell me -1. It is shifting down 1, but that's an equation. So y equals -1. You need to give me for the midline. And the range. What two things affect the range? Amplitude and midline. So an amplitude of 3 would give you a range of -3 to 3. But then I'm shifting down 1. So my final midline is going to be -4 to 2. Good? Okay. Now the graphing. The graphing is, in my opinion, the hardest part of this unit. If I ask for one cycle, you know what it's supposed to look like. If I ask for a certain interval, you should graph one cycle first anyways. So if you're going to graph, your first step is to graph one cycle. And we're graphing a sine graph, and what's this negative going to do to it? It's going to reflect it. So make a note that you're going to reflect. Okay, and then remember what I always do next. I always draw just a regular sine graph. Sine, where does that start? Below the midline, at the midline, or above it? At the midline. So you gotta know what these sine graphs look like. That's a regular cycle of sine. So the first thing you should plot is the midline. Okay, so here's pi equals -1. I need to start at the midline. So there's your first dot. Now the second dot usually goes above the midline, whatever our amplitude is. But since this is reflected, we're going to go 3 below the midline. So you can space it out however you want. I'm going to go every 3. 3 below would be right about here. Then I have to go on the midline. So 1, 2, 3, I'm going to go here. That's that point. Then I'm going to go 3 above the midline. Be right here. And then finally I'm going to end on the midline again. So when you connect your graph, remember to make it curvy. That's one cycle. Now when you're labeling, you don't have to label your y-axes as long as you went consistent. And I went by ones. But bare minimum, you have to label the end of your cycle as whatever the period is. So you need to have a 16 right here. If you want, you can go halfway and label this 8. And even if you want to impress me even more, go halfway again, give me 4 and 12. So that's the best label, but bare minimum, you need one number on here so that you can tell what the scale is. All right, now we can use that to graph over a specific interval. I want to graph between -8 and 8. Well, I've got 0 to 8. I'm just going to have to go to -8. So if I'm going to set up this graph, I'd probably make it more in the center like this. And let's make our scale first. I'm going to go the same scale. So every 3 spots is going to be 4. So 1, 2, 3. This is 4. 1, 2, 3. This is 8. There we go. -4 and -8. Okay. And midline still needs to get drawn. And this is why if they give you a specific domain, you still want to make your one cycle first. Because I can just copy some of this. This is going to go 0, 3 below, back to 0. So I know that's right because I did that over here. But if I were to go this way, what would the graph look like? Well, it wouldn't go down again. It would keep going on this cycle. Up, down, then it would have gone up. So over here, we're going to go 3 above the midline and back to on the midline. And now I've got my graph on that interval. Okay, and remember, you can always check too. So if I set up my original equation as -3 sine of pi over 8 x minus 1, and make sure the mode's right. Remember, when we're graphing, we want to be in radian mode. Okay. When I look at my window, if I'm checking this one, I'm going from 0 to 16. Can you make our scales this, well, what am I going by? By 4s. And then I'm going down to 1, 2, 3, 4, down to -4, and up to 2. And if you hit graph, you should see one cycle if you've set it up to show you one cycle. All right, and there you have it. Now if I do this one over here, the only thing I would need to change is go from -8 to 8. And then we should see this looking graph. And if you do, you know you've got it right. Okay, so hopefully that clears up some graphing. Again, if they give you a weird domain, always graph one cycle first, and then use that one cycle to figure out what it should look like. Okay, word problem. Connor's jumping on a pogo stick. He starts at a height of 6 inches above the ground. The maximum height he reaches is 19 inches above the ground, and it takes him 3 seconds to complete one jump. Determine a sinusoidal model in the form y equals a cosine of bt plus c for the height above the ground as a function of the number of seconds t since Connor started jumping. Okay, so how do you find a? A is that amplitude. It's going to be max minus min divided by 2. And it says the maximum height that he reaches is 19. What's the minimum? It's where he starts, 6 inches above the ground. All divided by 2. So this is 13 over 2. So you can say 6.5 or just 13 over 2. How do you find b? It's related to period. So you know that 2 pi over b is equal to period. What's the period here? 3, because it takes him 3 seconds to complete a jump. So he's starting at 6, reaches 19, comes back to 6. That's one jump. So the period is 3. So 2 pi over b equals 3. Okay, so cross multiply. You're going to have 2 pi equals 3b. And if you divide, you're going to get b equals 2 pi over 3. Okay, and then finally we need c. So if we're going to look for c, we want the midline, which is max plus min divided by 2. So it's going to be 19 plus 6 divided by 2, which is 25 over 2, or 12.5. So putting that all together, we have y equals, because they told us to use y equals, 13 halves cosine of 2 pi over 3 t plus 25 halves. All good? No, you should be screaming at your computer screen, because where does he start? He starts 6 inches above the ground, which is his minimum starting spot, or minimum height. So if this is what my graph looks like, what type of cosine graph is it? That tells us it's a negative cosine. That's the subtle thing, like in last night's homework, you got to watch out for. So this needs to be a negative 13 halves. Okay? All right, part B. Emma is hoping to make Connor fall off his pogo stick, because Connor's kind of annoying. So she tries a small wire at a certain point along his path. If the height of this wire is 5 inches, and Connor encounters the wire 10 seconds after he started jumping, will he trip on the wire? Okay, so you can picture what's happening. Here's Connor jumping on his pogo stick. Not exactly like a cosine graph. It's not as curvy, but kind of. And Emma's going to tie this wire at 5 inches. So there are going to be certain times when Connor's safe. He's jumping right over the wire. But if he's down in one of these spots, he's going to hit the wire. It's going to be unfortunate for him. So I got to see when he encounters it, 10 seconds. So that's t equals 10. So if I do y equals negative 13 halves times cosine of 2 pi over 3 times 10 plus 25 halves, I can plug that into my calculator. And again, check your mode anytime you do this. I know I'm in radians, so I'm good. So I'm going to do negative 13 halves times the cosine of 2 pi over 3 times 10, and both of those parentheses, including the cosine one, plus 25 halves. And I get 15.75. Okay, so he is above where that wire would be. So since this is bigger than 5, you're at one of these spots where you're above the wire. So no, Connor's safe. Emma's plans are foiled again. Connor will not trip. You're just going to go right over the wire. All right, so expect a question similar to that somewhere on the test where you have to write the equation and then use that equation to answer some question. Okay, let's go over the review sheet. Now, I'm not going to go over this too much because the nice thing is, even though this has been kind of a long unit, we have been doing a lot of this stuff over and over again. Evaluating was the first thing we did. That's this first section here. So drawing your picture, for all these, this is where you would draw a triangle. Labels, so this would be like 0, -90, -180, -270, -360. -135 degrees would be down here. There's your angle. You have to figure out your reference angle. What would this be? If this is 135, you subtract from 180, so that's 45. This is where you have -1, -1, radical 2. Remember, anytime you go left, it's negative, or down, it's negative. Then you use SOHCAHTOA. So cosine's adjacent over hypotenuse. Adjacent's -1, hypotenuse is radical 2. But then simplest radical form means you're not allowed to have radicals in the denominator. So if you multiply top and bottom by radical 2, this answer is negative radical 2 over 2. Now don't forget you can also check those on your calculator, but be careful of your mode. So if my mode was in degree, because this is 135 degrees, I'd be typing cosine of -135. And I get that big long decimal. But then you can type in your answer, negative radical 2 divided by 2, and you get the same big long decimal. All right, so that's this section. And watch out for quadrantals. And if it's above 360, what do? Just subtract off 360. Okay, so those have been on a lot of homeworks. Just remember, always draw your picture. We also started with conversions. If you're going from radians to degrees, radians goes on the bottom, so you multiply by 180 over pi. Degrees to radians is pi over 180. Remember, don't tack a random pi where there isn't one. So if I say convert 3 radians to degrees, you don't do 3 pi, you just do 3. 3 times, I'm going from radians, I want radians on the bottom, so 180 over pi. And then you'll get an answer round to the nearest hundredth. Okay, let's keep going. After we did all those, we started doing the all students tried cheating to figure out where each trig function is positive. This is just like the homework where I can give you, determine a trig function using a picture or using identities. And those are the only 2 identities you really know. I guess we know cotangents, cosine over sine. But okay, so this second bullet is talking all about those type of questions from the warm-up. So I don't think I need to go over those again. The graphs, we just did those too. Here's how to find all of the different pieces. We went over graphing one cycle or a given domain on the warm-up. I didn't go over getting an equation given a graph, but there's a couple of those on the back you can try. Remember, you always kind of want to draw the midline in if you can, because that's a little bit helpful. If you can't tell where the midline is, maybe do max plus min divided by 2. 8 plus 2 is 10, divided by 2 is 5, so here the midline's at 5. But drawing in that midline will help you with those graphs. Modeling, creating an equation from a given situation. We just did that with the pogo stick. If I ask for a regression equation, I think you're fine with those. And lastly, know what the tangent graph looks like. I'm not going to be doing a lot of crazy stuff with tangent, but just know that between 0 and 2 pi, we did this yesterday. Remember, tangent alternates from being 0 and an asymptote. So it'll help you to know that that's the tangent graph. And you can always use your calculator too. Okay, good. All right, so if you go through this homework assignment actually shouldn't take you all that long. Don't get tripped up on number 11, given that sine equals a crazy number, find cosine to 3 decimal places. What would I still have you do there? Yeah, I would still have you draw a picture. So this is telling you where to draw the picture in quadrant 2. And sine, even though it's weird, just label the opposite as 0.908 and the hypotenuse is 1. And then you can find the other side using Pythag. You can also use sine squared plus cosine squared equals 1 if you want to on this one. If you prefer that way, that's totally fine. Remember number 9's. Theta is in an angle and standard position. Its terminal side passes through 7, 2. That tells you to draw a picture also. Go over 7, down 2. There's your picture. And that also gives you 2 sides. This is 7, this is -2. Then you should be able to go on, eventually find sine. Some graphing, and another equation for you to figure out from a word problem. Okay, so I think this will be okay. Be checking your answers. You should have the answers attached. There is one thing I should mention that could show up on the test or the. And this is something we did talk about. I didn't show you this when we did it originally. I tried to draw it out. What's this showing you here? This is showing you what is a radian. And we've been dealing with radians this whole unit, but it's easy to forget what a radian actually is. It's the angle needed so that the length of the intercepted arc is equal to the radius of the circle. Okay, so this picture I have here is 1 radian because that length right here is equal to this length right there. If I were able to have a bendable ruler and measure that bendy length there, this curve distance would equal this straight distance. That's the definition of 1 radian. So knowing that, this is 2 radians because it's 2 radii long. Or this right here is 3 radians, which if you think about it, you should know because that should make sense. What's this distance here? You know that's pi radians. And what's pi? 3.14. So it should make sense that 3 radians is just a little bit before 3.14 radians. Okay, so I just wanted to show you that to remind you that the definition of a radian is the length or the angle needed so that the length of the intercepted arc equals the length of the radius of the circle. And that's why when I have a question like convert 3 radians to degrees, well again, right here, this green, this is 3 radians. So it's going to be a little less than 180. So when you do that question on the review sheet, convert 3 radians to degrees, they're literally asking you to find that angle. So your answer for that question should hopefully come out to be something that's a little bit less than 180. Okay, so I just wanted to show you that because that does show up on the regions quite a bit. All right, last thing, what you're not allowed to forget, we'll fill this sheet in for you so that you have this all filled out at the end of the year. Here's the trig unit. The biggest thing to remember and what shows up on the regions most often is equations. Y equals A sine or cosine, doesn't really matter, of B times X plus C plus D. Knowing how to get all the pieces of this. Okay, so you know A, how to find amplitude, is absolute value of A, and it's also max minus min divided by 2. You know B is the frequency, and remember what that means too. That's number of cycles between what? specifically between 0 and 2 pi. I don't use that a ton. We know that period is 2 pi over b. But again, more importantly, what does period mean? Period is a length of time, length of one cycle. Mesozoic period or something like that. Phase shift is c. Which is how much we're shifting left or right. And then finally, the midline is max plus min divided by 2, or y equals whatever that d value is at the end. It's the vertical shift. All right, so I think that's the main stuff you should remember from trig for the regions. Obviously, there's a lot more that we did in this unit, but that's the stuff you use most often on the regions. All right, so I think that's all I've got for review. Go ahead and fill out that review sheet, study for the test tomorrow, and let me know if there's anything you'd like to go over with me. Good luck.